Hey everyone, I'm Rick Balkin in the School of Education at the University of Mississippi, and I'm going to present to you today on why the declaration of statistically significant should die, and hopefully give you some ideas or thoughts about how we should be modernizing our reporting of counseling research and more broadly social science research. This is based off of my article, Reasons Why the Declaration of Statistically Significant Should Die, and it is published in Measurement Evaluation in Counseling and Development. Moving forward, saying that a method or practice should die was not my idea. It came in 1989 from Bruce Thompson, a past editor of MECD, when he asked the question, why won't stepwise methods die? In a similar vein, I'm asking our profession to eliminate the declaration of statistical significance. So I want to be clear here that I'm not saying we should abandon p-values, and we'll talk about that in a moment. Rather, I'm saying we should abandon the practice of saying that a finding is statistically significant. So we have some myths in the way that we understand statistical significance. For example, in extant research, we have previously defined the idea of the p-value being a probability that results are due to chance, or that it is the probability of an experiment being replicable, or that it's the power to predict the behavior of a population. And we've evolved since these definitions, and today we recognize these definitions as incorrect. A more correct definition was offered by Jacob Cohen in 1994, when he said that a p-value really represents, given these data, what is the probability that the null hypothesis is true? And then you can see that the ASA further refined that definition in 2016 as the probability under a specified statistical model that a statistical summary of data would be equal or more extreme. To take this even further, the idea that we can take a p-value and say our findings are generalizable is a fallacy. Rather, a statistically significant finding is specific only to the data that we've evaluated. So, understand that we have entered into a replication crisis, and we found this in 2015 when the Open Science collaboration decided to reproduce or replicate 100 studies in psychology. Of those 100 studies, 97% of them were statistically significant, but only 36% of those studies replicated the statistical significance. And beyond that, less than half identified the extent of the effects that were identified in the statistically significant findings. So not only did we have a replication problem where most of the studies findings could not be replicated, but when they were, the effects weren't as great. So we really have this idea that, if we are overly confident in our finding of a statistically significant result, maybe we shouldn't be. So why do we say something is statistically significant? Well, that's a practice that started in 1925 with Ronald Fisher, because he said, oh, about 1 in 20 is statistically significant. And, when you think about that, it's as if saying, well, God loves 0.049, but doesn't like 0.051. All right. It's ridiculous that we would say or that 0.049 is statistically significant, but 0.051 is not. What's really changed in the data? And by lowering a threshold to say something like 0.005, we simply kick the can down the road, because then 0.006 is not significant, but 0.005 is. Again, it becomes a little silly, to suggest that this dichotomous decision off of a continuous value has so much importance. Finally, statistical significance can be a result of simply having a large sample size. And I provide this heuristic example where you only have a 1 point difference in, say, a SASE score. And from that 1 point difference, if you have 100 participants, you don't have statistical significance. But that same 1 point difference on the substance abuse subtle scale inventory would be statistically significant if instead of having a sample size of 100, you had a sample size of 400. Again, the effect didn't change. All right, but the sample size did. So, statistical significance is sometimes overly reported due to a sample size, a high sample size, as opposed to an actual effect occurring. So, understand that the problem isn't the math. The problem is the declaration. Statistical significance has historically been misunderstood. It's inefficient because we're taking a continuous value and dichotomizing it, making a dichotomous decision. It's valuable or it's not. It's significant or it's not. It's not necessarily replicable, and it's easily manipulated by a large sample size. Moreover, we have journals that have limited the value, the reporting of statistical significance. And some have just banned null hypothesis statistical testing outright. Other journals, such as Journal of Counseling and Development and Measurement, Evaluation, and Counseling and Development, say, hey, augment your results. So what's the solution? Rather than say, hey, let's continue this practice of this dichotomous solution of a finding is statistically significant or not, I'd say, let's go ahead and continue to report the p-values, but let's also make sure that we're augmenting those results with effect sizes and confidence intervals of those effect sizes so we know the range of the importance of the magnitude of the findings. Moreover, let's change the way we report our findings. For example, instead of saying the multiple regression yielded a statistically significant association and reporting the F value, the P value, the effect size, and the effect size confidence interval, we could simply say the multiple regression yielded the following result. And now if that P value is 0.049 or if that P value is 0.06, it doesn't matter. We report the p-value, we report the effect size, we show the confidence interval of the effect size, and we have a more accurate understanding of the results. We've abandoned this dichotomous declaration. So, what needs to happen now? Maybe journals and governing bodies need to publish new reporting standards. Maybe as educators, we should stop teaching 0.05 as absolute law. And finally, let's abandon the phrase statistically significant in reporting our results. The goal is not to eliminate p-values, but rather change the way we report on those p-values. All right? This is a century-old dichotomy, and we should now be moving past it. I hope this presentation was helpful. And feel free to reach out to me at the University of Mississippi, rsbalkin@olemiss.edu. Be well, everyone.